Hello children, I am Prasad. I am a maths teacher. I have been taking maths for the last 30 years for all syllabi, for CBSE, for state board and also for ISC. Today, let me just introduce one particular topic which is a very simple topic as far as school exams are concerned. And if you go to competitive level, it becomes a very important topic and also slightly difficult topic. This chapter is complex numbers. What is complex numbers? See, up to 10th standard, we have seen number system that goes up to real numbers. We have natural numbers, we have whole numbers, we have integers, we have rational numbers, we have irrational numbers, and all these constitute another set called real numbers. And so real numbers contain all sets of numbers like natural, integers, rational, irrational, everything. So we have seen up to rational numbers. Let's see, when we came across with an equation like this, x square plus 1 is equal to 0. X square plus 1 is equal to 0, then what is x equal to? So we say x square is equal to minus 1. Now there comes a contradiction. What is that? You cannot say any real number whose square is negative. You take any real number and you square it, it will be always positive. So this is not possible when you are dealing with the real numbers, which means you cannot say a real number whose square is minus 1. If there is no such real number, which means that we are going to another set of numbers which are not real. So if x square is equal to minus 1, then x is equal to, isn't it square root of minus 1? Which means this is not a real number. Why? Because square root of negative numbers is not defined. Such numbers are called imaginary numbers. So what are imaginary numbers? Numbers that are not real are called imaginary numbers. Square root of minus 1 is an imaginary number. Why is it an imaginary number? Because square root of negative numbers is not defined. So such numbers will be imaginary numbers. So you can give some example. Square root of minus 2 is an imaginary number. Square root of minus 3 is an imaginary number. Square root of minus 4 is an imaginary number. So numbers like this are all imaginary numbers. So we need to give a place for these types of numbers also. So then comes the existence of this number called complex numbers. So what are complex number? I'll give you the definition, which is not the correct definition, but a definition which will be applicable, which you can now use it here. A number system which contains all types of numbers, real as well as imaginary, can be called as complex numbers. So what does complex number contain? Complex number contains all sorts of numbers that are real and that are imaginary. So these are imaginary numbers. Imaginary numbers can be accommodated in this set called complex number. But this is not the definition. We are coming to the definition. We'll see that later. But let us see something about this set. So what are imaginary numbers? Imaginary numbers are numbers that are not real. See, you have seen this when you studied the chapter called quadratic equation. I take one quadratic equation, x square plus x plus 1 is equal to 0. Right? And you know, see, to say the nature of roots of this quadratic equation, you find the discriminant, which is b square minus 4ac. What is the discriminant of this? This is equal to, what is b? The coefficient of x is b. So it is 1 square minus 4 into, what is a? The coefficient of x square is a. 1 into, what is c? The constant is 1. C, that is c. So 1 minus 4, which is minus 3. You get a negative number as an answer. A negative number means less than 0. And you have studied in quadratic equation, if the discriminant is negative, the outcome, the result, the solution of this will not be real. If it is not real, then the solution must be imaginary. We used to say that the roots of this are imaginary. This you have studied in 10th standard. So now listen, what type of numbers are imaginary numbers? See, these are examples of imaginary numbers. From 11th onwards, we are going to study about what these numbers are. So let me just wind up by saying complex number is a set which contains both real as well as imaginary. We'll come to the proper definition later. Okay, now let us see something more about imaginary numbers. We said square root of minus 1, square root of minus 2, square root of minus 3 are imaginary numbers, right? See, just for convenience, we take letter I as square root of minus 1. Just for convenience, we take square root of minus 1 as I. What is the use of taking this as I? So, square root of minus 2 can be written as, it is square root of minus 1 into 2, which is equal to square root of minus 1 into square root of 2. But what is square root of minus 1? It is I, so it can be written as I root 2. Or you say root 2I. So what will be square root of minus 3? Same manner, square root of minus 3 will be square root of minus 1 into square root of 3, which is equal to I root 3. What will be square root of minus 4? Square root of minus 4 will be square root of minus 1 into square root of 4. What is square root of minus 1? It is I. And what is square root of 4? It is 2, or you can say it is 2I. So now you can say any number which contains I along with it can be called as an imaginary number. I hope this point is clear to you. Okay. So I is the first letter of the word imaginary, and I is given a value square root of minus 1. Okay. When you refer some higher level textbooks, you will see that I is also called iota. So I is the first letter of the word iota, or you can say imaginary, and I has been given a value square root of minus 1. I hope this much is okay to you. Now let us see something more about this I. Listen. So we have taken I as square root of minus 1. I as square root of minus 1. Then what will be I square? If square root of minus 1 is I, so what is I square? See, it's very common that square root of minus 1 is I, then I square will be minus 1. But there is some problem there. It is not becoming minus 1, it is taken as minus 1. Remember, it is taken as minus 1. So now keep this in mind. If you take I as square root of minus 1, you should say along with it such that I square is equal to minus 1. I square is not becoming minus 1, we are again taking it as minus 1. Now there is a reason for it, we will study later, or you can also research and see why this is being said like this. Anyway, I is equal to square root of minus 1. So what happens to I square? I square becomes minus 1. So what is I cube then? If I is square root of minus 1, I square is minus 1. How can you write I cube? I cube, isn't it I square into I? But what is I square? I square is minus 1. So this is minus I. So it's better to write I cube as minus I. What about I raised to 4? I raised to 4 is, you can write this as I square into I square. What is I square? It is minus 1 into, what is I square? Into minus 1. What is minus 1 into minus 1? It is 1. So I raised to 4 is 1. Now, what about the other powers of it? Let me go for, say, I raised to 5. See, I raised to 4 is 1, right? Now, what will be I raised to 5? I raised to 5 is I raised to 4 into I. I can write like that because 4 plus 1 is 5. But what is I raised to 4? We got the value of I raised to 4 as 1. So, this is nothing but I. So, I raised to 5 can be written as I. What about I raised to 6? I raised to 6 will be I raised to 4 into I square. What is I raised to 4? It is 1. So, what about I square? It is minus 1. So, what is 1 into minus 1? It is minus 1. I raised to 6 is minus 1. What about I raised to 7? I raised to 7 is I raised to 4 into I cube. I raised to 4 is 1. into, what is I cube? See, I cube is minus I, so minus I, so the answer is minus I. What about I raised to 8? I raised to 8 is I raised to 4 into I raised to 4, so which is 1 into 1, so the answer is 1. So we are seeing what will be the change in I when you give integral powers for I. We are seeing natural numbers as powers 1, 2, 3, 4, 5, 6, 7, 8. You got I raised to 4 as 1. You got I raised to 8 as 1. If you have understood this much, can you tell me for what power of I next it will become 1? See, I raised to 4 is 1. I raised to 8 is 1. Yes, you said it right. I raised to 12 will be 1. I raised to 16 will be 1. I raised to 20 will be 1, and so on, which means when you have the power of I a multiple of 4, I'll write it as 4n, it will be always equal to 1. Did you understand this? What is n? N is a natural number. We have taken only natural number. Remember, it is true for integers also. We can prove that I raised to 4n will be always 1 for any integral power of I. Hope this much is clear to you. Let us see one question based on this I. So, listen, we are dealing with imaginary numbers. Just see one question based on this, how to deal with this question. This question has been asked for board level examination and also for entrance examination. See, I take I raised to n plus I raised to n plus 1 plus I raised to n plus 2 plus I raised to n plus 3. What is the value of this? See, this is equal to I raised to n. Now, this one can be written as I raised to n into I, applying the laws of exponents. What about this one? I raised to n into I square. What about this? It is I raised to n into I cube. Am I right? Now see, from these 4 terms, I can take I raised to n outside. So what do you get in bracket? 1 plus I square plus I cube. What is this? I raised to n into 1 plus I plus, what is I square? We just now saw I square is minus 1. What about I cube? I cube is minus I. See, 1 and minus 1 cancel, I and minus I cancel. So this becomes 0. So I raised to n into 0. So the answer is 0. I hope this is clear to you. So this is all about imaginary numbers. I hope this much is okay to you. So children, see, I'll give you one question. You can try by yourself. What will be the answer? You just try to find out. Say, I want the value of I raised to 1000 plus I raised to 1001 plus I raised to 1002 plus I raised to 1003. Just try this and see what your answer is. Okay, thank you children.